Now, let us try to find out the electric field due to a dipole. Let us select the point on the equatorial line. I will take a dipole. You know what is a dipole? Two equal and opposite charges separated by a very small distance. So I will take a dipole and let the positive charge be here and negative charge be here. Let the distance between the dipoles, between the charges of the dipole be 2a, and I will select an equatorial line. It is a perpendicular or equatorial plane, anything. Perpendicular bisector of the line joining the charges. So it will be like this here. Okay. Now, I have to place a test charge. Now, select a point P here. Point P. I want to find out the electric field here. Let the distance of that point P from the center of the dipole. You know all the distances are measured from the center of the dipole. Let it be R. I will write it later. Okay, let this be R. Now, join the 2 points. I have to place a test charge here in order to find out what is the strength of the field. Unit positive charge. Now, join these 2 points. So let this be a distance from plus q, and this is an equal distance from minus q. We know that these two are equal because this is the perpendicular bisector. It passes to the midpoint of the two charges. So this distance and these distances are equal. So the two sides of the triangle must be same, this side and this side. So if you take this as an angle theta, this should also be theta because angles opposite to the equal sides of a triangle are equal. So this side, what is the opposite angle? For this side also the opposite angle same, since the two sides are equal. Okay, now if you want to find out what is the electric field here at this point, place a test charge. Now ask the test charge, unit positive charge, how many forces you are experiencing or how many types of fields are here? Sir, there are two fields, there are two forces acting on me. One is due to plus q, another is due to minus q. Plus q is repelling me, sir, in this direction. So let us write it as E due to plus q. I'll write only the magnitude. And what about minus q? Minus q will attract this test charge, and I will write it as E minus q. And I will represent both of them by equal vectors. The magnitude of the vectors are same. Because in the electric field formula, you know it, electric field is given by 1 by 4 pi epsilon naught q by r square. Now for both the charges creating electric field here, q is same. Only the type is different. One is positive, another is negative. Magnitude is same. And distances are also same. These two distances must be same. Now what is that distance? Distance from each charge to the point. Suppose this is r from here to here. And this will be a and a because half of the full distance between the charges. If this is r and this is a, definitely this is root of r square plus a square. Pythagoras theorem. Right? This is root of r square plus a square because these two sides are at right angle. Okay, so this distance is same. This distance is also root of r square plus a square. Charges are same, so E should be same. So when I select the lines for representing the vectors E plus q and E minus q, I should decide the same length, but their directions are different. Okay, now let me draw a parallel line here to this line joining the charges. Simply I will draw a parallel line for my convenience like this. Now if this is angle theta and if this line is parallel to this line, this green line is parallel to blue line, the red line is a bisector. If this is theta, this is the corresponding angle theta. And if this line is parallel to this line and if this is the bisector, this is alternate angle here, theta. So these angles are equal and this angle is also equal. Now, because I have drawn all these angles, you have two electric fields. What is the resultant of these two electric fields? Either you can apply formula of finding the resultant of electric field, two electric fields using root of a square plus b square plus 2ab cos theta. But here whole theta is 2 theta. Or instead of that, you can go for components. That is the best choice here. You can get the answer very easily. What I can do is, I can split this electric field which is along this direction. If you want, I can name it as A and B and P, which is along AP. That electric field can be split into two components. one along this direction and another along this direction. You know that any vector can be split into two parts. So when you have a vector along this direction, like this way, at an angle theta, if this is vector A, you can write A cos theta along the direction where you have taken theta. Along the adjacent side where you have taken theta, the component of this vector is A cos theta. What about here? A sin theta. So any vector can be split into two components, A cos theta and A sin theta. So that makes our job very easier. So you split this vector E plus Q into two components. One is here E plus Q cos theta and another here E plus Q sin theta. So one vector or component of this sin theta here, another cos theta. Wherever you have taken theta, you get cos component. Similarly, this vector, this electric field can be split into two components. One is here is theta. So E minus Q cos theta, because there is theta here, adjacent side now. So wherever you have theta, you have cos component, E minus Q cos theta. Another component of this in this direction, that is E minus Q, E due to minus Q sin theta. Now already we have told that this E plus Q and E minus Q are using the same formula, this formula, and moreover their values are same. Q, magnitude of Q is same, distance is this one, root of r square plus a square. So when all the things are same, only the directions are opposite, or not opposite, directions are something different. Their component E plus Q cos theta here, E minus Q cos theta here, they are same in direction, they can be added. What about their component in the vertical direction? The component of this in this direction, the component of this in this direction, E minus Q sin theta and E plus Q sin theta. Of course, this is E minus Q sin theta. I will write it here, E due to minus Q sin theta. So it is downwards like this component. So they are in the opposite direction. So E minus Q sin theta and E minus Q sin theta cancel each other. E plus Q sin theta, sorry, E plus Q sin theta and E minus Q sin theta cancel. The vertical components cancel. What about the component of these two in the horizontal direction? They add up because they are come in the same direction. They don't come in the opposite direction. They add up. So that is the final electric field here. So hope you have followed what you have found out. Electric field due to this is like this along AP. Electric field due to this is along PB, because unit positive charge will be attracted by minus charge, repelled by positive charge. So if you want to find out the resultant of these two, get the components, and among the components, vertical components cancel each other, whereas horizontal components add up. So what is the resultant electric field at P? So at P, resultant electric field is resultant electric field. And remember, nowhere I have written vectors now. I haven't written any vector here or here, anywhere. Resultant electric field is E is equal to E plus Q cos theta, and electric field due to minus Q, its cos component, E plus Q cos theta and E minus Q cos theta. And now I can write the vector here. How? Because finally the vertical components have cancelled. There is no electric field in this direction. Only electric field exists in the horizontal direction like this. This direction is opposite to the dipole moment. You know the dipole moment P or P cap or P vector is directed from minus charge to the plus charge like this. But this final answer, when they add up, they are directed towards the right, which is opposite to P cap. So I can write minus P cap for the final answer. So this one into minus P cap. That's what I can write. Because the resultant electric field in such a direction that it is opposite to the dipole moment P. So now let us try to go for mathematical steps. You know E plus Q and E minus Q. You can write the formulas for E plus Q and E minus Q. Let me write it here for the time being. E plus Q or E minus Q can be written magnitude wise is equal to 1 by 4 pi epsilon naught, whether this one is the charge taken or this one is the charge taken, anything, Q divided by magnitude, distance square. When you square the distance, root of r square plus a square whole square will be r square plus a square. So now substitute this formula here for E plus Q and E minus Q. Both are same. Okay, only the cos components add up. Vertical components cancel. So if you write this formula, net electric field at P, E is equal to, okay, E plus Q, 1 by 4 pi epsilon naught, magnitude of Q, and divided by root of r square plus a square whole square. From plus Q to here, minus Q to here. Both the distances are same. Root of r square plus a square whole square means it is r square plus a square. Root will go because root of r square plus a square whole square. This cos theta, that is E plus Q. Similarly, E minus Q plus 1 by 4 pi epsilon naught Q by r square plus a square, same value, cos theta into minus P cap. Now, I will write minus in the beginning of the formula. I will write minus here. Electric field net is minus P, minus into. And you can take all the common terms outside. Here 1 by epsilon, so this is same as this one, right? If I take this as x, this is also x, it is 2x. So I can write minus 1 by 4 pi epsilon naught, 2 times q, this one plus this one, 2 times q, r squared plus a squared, and cos theta. So if you take this as 1x, this is another x, it is totally 2x, 2 is here, into p cap, minus sign I have put it here, okay. Then the next step, I'll have to take another paper. 1 minute. Yes. Okay. Now I'll continue it. Right. Now, what is the electric field at the point P on the equatorial line? E is equal to, okay, we will substitute for cos theta now, minus 1 by 4 pi epsilon naught 2q divided by r square plus a square, then cos theta. What is cos theta? If you come back here, what is cos theta to the diagram? Cos theta is, you can take cos theta here, adjacent side divided by hypotenuse. What is adjacent side? A. So I will write cos theta here. Cos theta is equal to adjacent side A divided by hypotenuse, root of r square plus a square. I can write root of r square plus a square as r square plus a square to the power half. So cos theta is a by root of r square plus a square. So shall I put it here only? This becomes easier now. Okay. Yeah. So electric field E is equal to, so you have to get cos theta. Actually you want this one here now. This is over. Okay. I will make it visible. Just to write one step. Okay. Minus 1 by 4 pi epsilon naught 2q divided by r square plus a square cos theta. Cos theta is a divided by adjacent side by hypotenuse, root of r square plus a square to the power half I write, into p cap. That is the previous formula. So cos theta is this one. You refer the diagram. Okay. Or I can show it like this again here. Cos theta we have written here already. Cos theta a by r square plus a square to the power half because it is root. Right. Now I will continue. So what is the electric field? Now you have 2aq. You know that 2aq is the magnitude of dipole moment. I can replace it here. Electric field E is equal to minus 1 by 4 pi epsilon naught 2aq. I can replace it at P divided by, this is 1 to the power 1, this is to the power half. So totally 1 plus half, 3 by 2. R square plus a square to the power 3 by 2 P cap. Minus P cap, minus is here. Now, so this is one formula. Of course, this formula is also correct. Now suppose the distance chosen is very large compared to the size of the dipole. Suppose this R is very large compared to this A, then what you can conclude? Usually it will be so because dipole is a system of molecular size. So if R is much greater than A, then R square will be much greater than A square. I have given examples in the previous session also, because suppose you take R as say 25 centimeter, A is only 2 centimeter, then R square will be 625, A square will be only 4. So you can neglect that. Even if you add it, there is no much difference. Then what will be the electric field? Electric field is equal to minus 1 by 4 pi epsilon naught P divided by this is R square plus A square to the power 3 by 2 is R square to the power 3 by 2 P cap. So what is E equal to? 1 minus 1 by 4 pi epsilon naught. This is square will get cancelled, only cube will remain. P by R cube into P cap. See the previous equation, electric field due to a dipole on the axial line is 2P by R cube. This is simply P by R cube, but its direction is opposite to the dipole moment. That one you have to remember. Whereas in the previous derivation, it was in the same direction on the axial line. It was same as in the direction of dipole moment, but here it is opposite to the dipole moment. Dipole moment is from minus q to plus q. The direction of resultant total of this will be in this direction. No electric field is in this direction, it cancels. So this is the final formula for electric field at a point on the equatorial line at a distance r from the center of the dipole. This one. Thank you.